Short video talking about scientific notation, right? So, scientific notation is a way to make it very simple. Take either really big numbers or really small numbers and make them easier to read. I mean, honestly, that's really all it is. People get scared when they see it. It's a nice way to write numbers. It makes our lives easier, so we should do it in science. At least I think. Right? Hopefully, you agree with me. So what do I mean by this? Big number, small number, make it easy. Well, if I have, the number, I don't know. Let's do this. This number. Okay. I'm going to make this not as long as the normal number because I'm kind of losing track already of how many zeros I've drawn. You can see how beautiful I draw with my mouse. No errors at all with the way I draw my zeros. Quote unquote sarcasm. All these zeros, that's a lot. If I said, what number is this? And you go, 6, yeah, you're probably doing that right now. You might be saying, you know what, I can go, right? Oh, okay, that, right? I can start doing this. Even then, though, who knows the name of this number? Is it a hextillion, a septillion, a octillion? Numbers that get silly, okay? So a number this big, we would never, ever, ever write it like this in science, right? Because it would be obnoxious. So what we would do instead is write it in scientific notation. Okay, how would I do that? Well, it's simple. I got to find the decimal. The decimal right now is, I don't see it, probably at the very end, right? That's what you assume if there's no decimal drawn. And then you got to count backwards how many decimal places until I get here. Okay, scientific notation, some basic rules. There's only ever one number in the ones place. Okay, so I don't care how big the number is, I don't care how small the number is, there's only ever one number in that ones place. Okay, so this 6 will be in our ones place. Okay, I can't do 60, I can't do 602, I can't do 6022. I'm going to have to start with a 6. Okay, so I'm going to count back. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Wow, I draw a lot more zeros than I thought. So 31 times. Well, so what does this mean? It means I have 6.022. You say, where are those numbers coming from? That's these numbers right here. Okay, I have to include up to the last non-zero. Okay, now I don't want to scare you, but if we were working with significant figures the correct way, we would actually have to know whether or not these zeros are significant. But that is a different topic. Okay, so for simplicity purposes, we're looking for that last non-zero. Okay. Again, if you're taking a physics class, a chemistry class, you're in college taking a class like this, you are probably going, wait, don't we have to know if these zeros are significant? And that's true. But if you're taking a freshman physical science class, for example, then it doesn't matter. Okay, so if I wanted to make a more advanced video, I suppose I could, but this is just simple. Okay, and for that level, it's fine. Okay, so 6.022 times 10 to the 31st power, because I counted 31 decimal places to get back here. Okay, this number here is the exact same thing as this number up here. Okay, and I'm sure you'd agree, I would hope you'd agree, that this is way easier to look at, way easier to say, way easier to understand than this giant number up here. Okay, so hopefully you're saying, okay, I kind of get it, tell me more. Okay, basically, when we do scientific notation, right, the premise is that we have our significant digits, the numbers that are non-zeros, represented in the front of this large number or this very tiny number. Okay, so if I have, let's make a simple example. By the way, you would never, ever, ever, ever do this, but just to prove a point, if I had the number 7 and you said, can you put this in scientific notation? The answer is I can, but why? Okay, what would it look like? It would be 7 times 10 to the 0th power. Okay, if you're like, what? Remember, any number raised to the 0th power is 1. So this is 7 times 1. Okay, again, there is absolutely no reason to do this. All right, but if you're like, could you? The answer is, yeah, I guess you could. Okay. What if I had the number 71.5? Again, I could write this in scientific notation, except now I got to move that decimal place over 1. So this would be 7.15 times 10 to the first. Okay. Notice these exponents have all been positive so far because these numbers are all bigger than 1. Okay. Which means if there's going to be an exponent, it's either going to be 0, 1, or higher. Okay, hopefully that part is making sense. All right. You could also do very small numbers. So if I said to you, for example, like a millimeter, right? A millimeter is 0.001 meters. That's a millimeter, right? If I wrote this in scientific notation, it would be 3 decimal places over, right? So that would be 1 times 10 to the negative third, in this case meters. Okay. 1, of course, because that's this digit right there. But the negative third, or negative 3, I should say, because this is less than 1. 3 decimal places. Okay. You could say to the right if you want. I mean, it depends on how you perspective this, if that makes sense. But the idea, realistically, is that this number is smaller than 1. Okay, you can easily take these numbers and turn them back into what's called standard notation by just doing what the math says. It says take 1 multiplied by 10 to the third, or 10 to the negative third, which means take a 1 and move the decimal place 1, 2, 3 places over. Okay, so this would be 0.01, 0.001, I should say. Okay, as you can imagine, this makes really annoying numbers easier to see. So, in chemistry, one of the most important units is called a mole. And a mole is this number. Ready? 6.022 times 10 to the 23rd. Okay? In the beginning, I showed you a number that looks similar to this. I just kept spamming zeros, and I got 31. But this would be 23. Okay? It's still a giant number. It's almost a trillion. Okay? It's a very large number. But the premise is this is way easier to see, way easier to say than if I had another number. And that's basically it. The only thing I'll add is please never, ever, 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 ever say, oh, negative exponent, that must mean it's negative. No, it just means that it is a very small number. Okay? If you want to, just give you a little math lesson here real quick before you turn this video off in disgust because I said math. 10 to the negative 5th is the same thing as 1 over 10 to the 5th, okay, which is what makes it small, okay? So hopefully that all makes sense, and hopefully you're saying, oh, that's not that bad. That's the hope. We'll see.